lecture number 6. I was talking about one thing which I want to clarify last time. So this was about the for loop and the while loop being logically equivalent. This is true with C and with programming languages that come after C. But with more simple programming languages, for example with BASIC, it is not true. Because in BASIC, actually the earliest BASICs, it didn't even have a while loop, but in the BASIC variants which have a while loop, the while loop is much more powerful than the for loop, because in BASIC the for loop only allows you to count. You start with a variable, you have an initial value, you have an end value, and you say you decrease it or increase it by a certain number in each step. That is what we can do in BASIC. But in C, you can actually do much more, because a for loop is just a while loop with a different syntax. So you can, for example, check if a condition has been met. It doesn't have to be simply that the counter variable has reached a certain value. It can be any condition. So you can also combine conditions. You can do conjunctions of conditions or disjunctions of conditions, negations, and so on, as I told you about in the lectures on logic. So this is also the reason why I started this series of lectures with lectures on logic, because you need these things for loops, for conditional statements, and yeah, and loops and conditional statements are things which you need if you make a program. So you will only make very simple programs without using loops or conditional statements. Of course, in the first versions of BASIC, you didn't have a while loop, but you had goto. So goto was a dreaded command that told you to go to a certain position in the program. And so it was quite difficult for another programmer who hasn't written the program himself to find out how a program works, because there could be jumps within the program from any line to any other line, and you couldn't easily see when a certain line would be called, or if at least there is, if at all there is a jump to this line. So this was also called spaghetti code, and this is actually deprecated. So even in C, there is the goto command. Actually, you can define labels and you can go to these labels, but it may be not intuitive, but you can actually do anything you can do with goto, also with while loops, for loops, and function calls. So you never have to use goto. You can always write a program that does not use goto. But honestly said, if the program compiles to machine language, then in machine language commands similar to goto are used, so the jump command and the conditional jumps. So machine language actually has no while loops and no for loops. They are expressed as conditional jumps or as absolute jumps. So actually, ultimately, while loops and for loops are converted to goto statements, so to speak. But the thing is, machine language is difficult to read, and it is only for the computer to process. And if you write a program in a higher level programming language, such as C, for example, or C++, then you want to make it such that it becomes legible, understandable, comprehensible. And that is why you should avoid using goto. So this was just a clarification regarding a statement I made in the previous lecture. What I actually wanted to talk about in this lecture is two topics, and the first is generic functions and the other is object-oriented programming. Generic functions. I was talking about functions having an input data type and an output data type, or if they have several parameters, several input data types. But actually, as I said, if you sort something, you sort lists, but it could be lists of decimals, this could be lists of strings, or lists of something else, yes? So, why should you actually write a sorting function for each of these data types? In fact, the sorting algorithms are universal. You can use quicksort both for lists of decimals and for lists of strings. So why should you write two different code snippets? Just write a quicksort algorithm once and use it for everything. But that is something that is only possible since a short time in programming languages. So in C, this was not possible yet. So as far as I know, generic functions was first introduced in Java, and then in C#, and then in C++ actually. So, but I'm not sure if this order is absolutely correct, but this is how I remember it to be, and definitely in C there weren't generic functions yet. So this is actually a pretty new feature, considering that Java is a programming language that was introduced in 1995 or 1996, as far as I remember, with C being already several decades older. So with generic functions, you can actually define a function that accepts any data type, or at least a wider range of data types, but you have to mind one thing. If you implement quicksort for decimals or for strings, then basically the sorting algorithm is the same. But the big but is that you have to treat the data types differently. The comparison function is different. If you compare decimals, you can easily compare them with the simplest comparison operators, greater than or less than, lower than. But if you have strings, so if you have strings that resemble English words like house, car, doll, dog, or something like this, well, in some programming languages, the comparison operators are overloaded. That means that they also work with such more complex data structures. But this is not always the case. And so it might be that you would need a different comparison function for strings than for decimals. So what you do is that you define a sorting function and say it uses a comparison function. And the sorting function can be generic, so it can be for any data type, or at least for a list, but at least for several possible data types. But then the comparison function actually is not generic, but there are several comparison functions for different data types. So this is how you would usually do it nowadays in modern programming languages. So you don't have to write the same code over and over again. And this is far more elegant. And what I also wanted to talk about in this lecture is object-oriented programming. Basically, object-oriented programming is an extension of procedural programming, which itself is a type of imperative programming most of the time. Well, okay. Functional programming is also employing functions, of course, but in procedural programming, actually, it is different from the old basic programming language, where you had just one program and you had line numbers, and you could jump to each line by specifying go to the line number, but there were no procedures. Procedures are some kind of sub-programs. So I was talking about functions. So actually a procedure is a function of the void type. And in the old programming languages, such as BASIC, you didn't have such functions or procedures. So procedural programming is the programming paradigm that allows you to create functions, or at least void functions, and thus encapsulate parts of your program. But in object-oriented programming, this is a kind of an extension, and it is actually, I was talking about structs in the previous lecture. A struct is a data type that is a compound data type. So you can have, for example, a linked list can be defined as a struct of a primitive data type, such as decimal, a primitive data type such as decimal, and then a pointer to another list element. So this is for structs, but the structs in C only have variables, only have data. So an object actually is nothing but a struct which, in addition, can have functions. And in this case, the functions are called methods of the object. So you can actually not only encapsulate data, but you can also encapsulate code. And this is a paradigm of programming that is not supported in C, but it is supported in C++, C#, Java, and also many other programming languages. So C is not an object-oriented programming language. It is a procedural programming language. But C++ is an object-oriented programming language. C++ does not force you to work with objects. You can program in a similar style as C with C++. Actually, almost all C programs can be compiled with a C++ compiler. So there is some sort of compatibility. The other way around, of course, it is not possible. So with a C compiler, you cannot usually compile C++ programs, especially not if they make use of objects. Object-oriented programming actually, it is supposed to make the code more readable. It's the same with procedural programming. You can define which functions actually affect which objects, or let's say which data structures which they affect. And so it is not like this that the functions are sub-functions of the main program, but they are sub-functions of the objects. So you group the data with the methods for handling the data. And this is, well, it is more elegant actually. It may also make life a bit harder, but it is more elegant. And it is also more elegant because you can define members of functions, also both data and methods, as private or public. So if a member is public, then you can access it from the outside. If it is private, then you can access it only within the object. And this is supposed simply to prevent that some data, for example, is overwritten accidentally. This is especially relevant when you're working in a team of several programmers. So the programmers can, for example, work each one on one class. So a class is the general term, and an object is an instance of the class. So it's just like you say integer. The data type is a class, and then a certain integer variable is an object of integer. And what is also interesting is that you can make classes inherit from superclasses. So classes can be subclasses of other classes. So this allows you to write some sort of specialized code. You can, for example, devise a more general class, like class animal, and then you can create a subclass which inherits from animal, but which is called dog and contains specific methods and data structures for the dog. Because every animal, for example, is eating food, so you can't have a method eating food. And the dog will inherit this method because the dog also eats food. But what not every animal can do is bark. A dog can bark. So the method bark would only appear in the subclass dog. So apart from public and private members of a class, you can also have protected members of a class, which are accessible by related classes. So this is also a third thing which you can do, because otherwise, if you define a class and declare variables as private, then only members of this class will actually be able to access it. So if you have a subclass, for example, and you want to write a method in a subclass that accesses these private variables, you will fail. You have to define these variables as protected in this case. So object-oriented programming can sometimes be considered, well, a science of its own, or at least something that you need to deal with a bit more thoroughly to really understand everything about it. But actually, I have explained the gist of it in these few minutes. So if you have been able to follow what I said, you know what object-oriented programming actually is. So object-oriented programming is actually the standard way of programming nowadays in professional projects. No matter whether you are working with Java, C++, or C#, then you are usually writing object-oriented programs. So procedural programming is more or less outdated, or you might use it for some scripts, for example scripts in Python, but usually the way a program is made is the object-oriented way. So thanks for your attention. I will close this lecture. So see you again in another lecture.